Hi, my name is Ted Shirk and I'm making this video as part of my application to attend the Equinox Summit Forum. I thought I'd use this video as a chance to explain my interest in the summit and profile some of the low carbon initiatives I've been involved with. I guess the main appeal for me of participating in the forum is to observe how science and policy can work together to achieve a low carbon energy future. In the supporting documents for this application, I've already detailed my background and the skills and knowledge I can bring to the forum discussions. So instead, in this video, I'd like to focus on showing the selection committee how these initiatives have looked in the built environment and introduce you to some of my colleagues. These are the people who I've been working with in collaboration to advance low carbon energy technologies in the context of my work at the Toronto and Region Conservation Authority. So here I am at the offices of the Sustainable Technologies Evaluation Program, and as part of my application video I wanted to introduce you to a couple of my coworkers here. The first of those is going to be Alex Waters, who's the director of the Courtright Center for Conservation. Hi Alex.
Hi, you're Ted.
So I was just wondering if you could tell us a little bit about what happens here at the Courtright Center. I'm going to be talking to David, who works for the Sustainable Technologies Program, and so I was just wondering if you could tell us a little bit about the renewable energy demonstration projects we have here and the education programs at the Courtright Center, and maybe if you could tie that a little bit into low carbon energy technologies. That's sort of the theme of the video.
Okay. Courtright Center is owned and operated by the Toronto Region Conservation Authority. It's the largest environmental education facility in Canada, attracting over 120,000 people, 80,000 children. We have a whole variety of environmental programs, but one of our most popular ones is based around our green buildings and renewable energy technology themes. We have the largest demonstration of renewable technologies and green buildings in Canada, and so we have a whole variety of education programs based around that. We have school programs, but we also have public programs, which are one-day workshops, right up to one-week workshops, where we can teach trades and professionals all about photovoltaics and that kind of stuff. But to make sure we're giving the right information, it's really important that we have the proper data behind those technologies, and the STEP program is an invaluable tool to be able to pass on the appropriate information to homeowners and businesses, so that we're testing both wind turbines and photovoltaic systems, solar hot water heating systems, green buildings on the property, so that when we're talking to homeowners, we're talking to businesses, we can say these technologies actually work. We have the scientific rigor to be able to prove that and make them feel comfortable. So it makes a whole shift to a greener economy much more valuable, and has a bigger impact on homeowners when they know that things have been tested and they're getting it from a third party. We don't sell any equipment, so it's really important that they realize it's unbiased information that they're getting from us. And when we're talking about the low carbon economy, that is all part of the messaging. It's all about energy conservation, which reduces the amount of the carbon footprint of homeowners and businesses. Renewables is the next stage of that piece in terms of reducing your carbon footprint to the point that you can be net zero. We're not quite there yet, but that's what we're working towards. And with all the scientific data that we're collecting, that we'll be able to show what technologies are better, which are more cost effective, which are durable products out there. So between the education programs, the demonstrations that we have, and the STEP program, it's an invaluable combination of opportunities to really move the technologies and the low carbon society forward.
Okay, thanks very much for that. So it turns out that the manager of the Sustainable Archetype House, David Nixon, who's the fellow I'd wanted to talk to, is away today. But one of the other technicians has graciously offered to tell us a little bit more about the PV test field and some of the other monitoring systems they have set up at the Archetype House. So I'm here with one of the technicians at the Sustainable Archetype House, Gil M. Dursky.
Hello.
How's it going, Gil?
Good. How are you, Ted?
Pretty well. So yeah, Gil's going to tell us a little bit about the monitoring systems that they have set up here at the house. And just outside, as I just showed you on the video, there's a PV demonstration and monitoring site, or PV test field. So we're going to talk a little bit about that as well.
Yeah. Okay, so what we're doing here is actually a major part of the PV test field was to see snow shedding and the effect of albedo, i.e. the reflectivity of the sun's rays on the snow, how that would affect snow shedding on the PV modules. So one thing that we've done is we have N-phase inverter modules on each of our PV modules. Now that lets us see individual, power tracking and monitoring and things like that. And this is our array here.
What are we looking at here?
So you can see here, this is just a physical representation of each of our inverters right now. And as you can see, this front array here, we have actually 9 different pole mounts, each at different inclinations. So here we have about 0, 10 degrees, 20 degrees, 30, 30, 40, 70, 80, and 90 degrees.
So the idea is to sort of test the effects of different
different
angles?
inclinations, especially to do with our climate and our azimuth, and especially with our harsh winters. Some people put up large solar farms or things like that, or even in your home you have areas where you can't really reach and clear off that snow all the time, or if it's an area that you'd have to drive out to. So we're trying to really optimize and see what's the best outcome here, the best thing we can do.
And I guess it's also about getting good microclimatic data for Ontario. Building up that database of really good good high quality irradiance.
We're actually mimicking a study that was done out of Queen's University that is doing pretty much the exact same thing that we're doing here.
Cool. So we're collecting lots of data. We know pretty much everything that's going on out in that PV test field as far as irradiance and PV production. Yeah, PV production, irradiance, temperatures. We also have a snow gauge that we're gaining data to. I could pull that up, but that would take me a while as well. No, that's great. That's probably a pretty good overview just for this video. So thanks a lot, Gil. All right. And there you have it.